Welcome back, students. I believe you are still kicking very well. Today I want us to look at trig functions. This will cover grade 10, grade 11 and grade 12 functions, specifically trigonometry functions, and there are some things that you guys missed from grade 10 and I want you to remember them, and they are very quite basics. Once you get these basics, you are not going to have so much of a problem. I want us guys to talk about the equations. Once we understand the equations, we are not going to have a hard time. We may have y is equal to a sine xb plus q, or we may have a cos xb plus q. We may have a tan xb plus q. We just need to understand why the a's and why the b's. What are they for? Once we understand that, we won't be having any issues. By the way, a tan does not have an amplitude. Let's just do it like this. So now the a before the cos, that tells us about the amplitude. For an example, when we look at the graph of a cos, it's something like this. So the distance between the x-axis and where the graph tends, that is your amplitude. Or maybe if you are looking at the sine graph, it's something like that, as you are looking at the sine graph and so on. So the distance between the turning point and the x, that will be your amplitude. So it is determined by the number before. So for example, if I'm going to have 3 cos x, as an example, 3 cos x, I expect to see a very long graph like that with a distance of 3 units between that's where the amplitude is. So it will be measured by that 3 that comes before the cos. So we just need to understand that a is the amplitude. It's how not wider, but how long the graph is vertically. Okay, and then in this case, with the q tells us about the range. Q is the range of the graph, and we want to understand what is the range. For us to understand what is the range, I'm going to do this as an example. Let's say maybe this is what you have, and then you find out that the graph tends at -4 for some reason, and then there it's +4, and we want the range. The range of a function graph talks about the space that the graph fills, so it's going to cover exactly from this sort of an asymptote line. So the graph covers from 4 up to -4. So when you give the range, you are going to say y is the element of, you can put a square bracket and then say the graph, it's from 4 up to -4, and then that's it. It never goes beyond, or it never goes below. All right. Similarly to the sine graph, we may have something like that, and so on. And we do this, we say, well, the graph tend at 1, and then we had -1. And when we say give the range, well, that means you're going to say y is the element of from 1 up to -1. It never goes beyond or goes below. That's why we use the square brackets, because it never goes beyond or below. So we can use the square bracket. So I advise giving a range in that way. It's never complicated. So you need to understand a full formula. For example, if we say sine x, maybe 2x plus 1, you need to understand that the a is the amplitude. If there's nothing, it means a is the value of 1. This is going to be the asymptote, which is the range. It's the asymptote. So we're gonna talk about how it affects the graph from the original. I was just introducing the formulas, understand what is the q and understand what is an a. What we haven't talked about is the b. We want to understand what is that b for. Well, I'm just gonna wipe this one. The b, this is the period. This is the period of the graph. For an example, we can say to you y is equal to maybe 3 sine x 2x. Then we say calculate the period of this graph. The period of this graph, you have to know the formula of a period. The formula of a period is 360 divided by the value of b. The value of b is any value before your x. So if we see, let's say for an example, sine x, the value of b here is going to be 1. Okay, so in this case, for the period of this graph, we are going to say 360 divided by, and then the value of b is going to be our 2. So that means the period is going to be 180. So that's how you get the period. So you must know what a is and what it does, and what b is. It tells you about the period. You can identify the period from the given formula. And then the q, it's about the graph going up or down. This is the vertical shift. Another way that I can put it is not only the range. Let's put it as it's a vertical shift. Vertical shift. This tells us whether the graph shifted up or down. If it's positive, it means the graph went up. And then if it's negative, it means the graph went down. So I want us to start drawing the graph of the original sine and a cos and a tan, so that you understand what happened when you see a different one. I want us to start with, I'm just going to say f of x, rather. F of x is equal to sine x. And I'm going to use this. And I want you to stay with me. on this one. So as a result, we can say, I'm going to use the 90 here, 180, 270, and lastly 360. This is 0, -1, -2, 1 and 2 and 3 and -3. I want to show you what happens when we make some few changes. Okay, you just go to a calculator and then you press a sign, and then the calculator will open the bracket for you, and then you put a 0, and the moment you put a 0, your graph is going to be at 0. It's gonna tell you 0. You can just check for yourself, and then from there you say sine, and then you put 90 there, and then you are going to get a 1, and then you're going to be here, and then you say 180, it's gonna give you 0, and then you're gonna come back here. You say 270, it's gonna give you -1, then you're gonna make a point at -1. You take your calculator, sine 360, it's gonna give you 0, and then that's where you'll be. You just trace those dots. You're going to start from 0, and then you draw. This is your turning point, just nicely so, and that's how the graph will look like. This is the original graph of a sine. Now I want you to check, this is, by the way, f of x. This is f of x. So let me just say f. This is our f. I want you to note the graph of g of x the moment we put a sine x, let's say +1. I want you to understand what the q does on the graph. This is the original graph. Next time when you see the following shape, you know what happened to it. And by the way, we should know that the graph of sine walks like a snake. It walks like a snake, and then the graph of a cos is like a plate, so it's gonna go like that. This is the shape that it takes. So you should be able to identify the shapes and so on, but we're gonna get to that later on. So in this case now, the fact that we put a +1 there, you're gonna go to your calculator and say sine and then put 0 and say +1. It's gonna tell you for you are at 1, and then you say sine 0 plus sine 90 plus 1 is gonna give you 2. You'll be there. Then 180 is gonna take you at 1. 270 is gonna take you to 0, and then 360 is going to take you to 1. You can just confirm with your calculator, and then you realize that the very same graph that we had kinda went upwards. Can you see that your graph went upwards compared to the original one? This is because the graph went up. If we set negative, this is how the graph will definitely look like. So that's what happens to that. Okay, that's what happens. So for now, I want you to understand the effect of that Q, what it does on the graph. And then we are going to do something very interesting. Again, this is the graph of G, and then let's go to the graph of H. The graph of H this time around, by the way, before we go to the graph of H, I want us to discuss the amplitude of the F. The amplitude, we take it from the turning point, so that means the amplitude here is going to be 1. Now, what is the amplitude of the second graph, the graph of G? You need to listen very carefully and watch very carefully before you identify your amplitude. When you are given the Q, please draw the asymptote. Remember, the Q is the asymptote. You draw it at 1. Just make a very beautiful line. Make a very beautiful line like that, and then now you can be able to identify the distance between the new x-axis, because this is your new x-axis now. So the amplitude is still 1. So someone will think now the graph of G, the amplitude will be from the x to the turning point, and that will be wrong. Remember, your graph went upwards, so that means the x-axis shifted upwards. So that's how you identify the amplitude of the graph when it has shifted. Before you identify, draw the line. Even if we said -1 here, we were gonna draw the line of a -1 and then identify the amplitude. Well, in that case, let's go for the H graph. With the H graph, we understand that this will be something like, I'm going to say sine into x minus 30. X minus 30. Well, we need to understand that next time when we say sine x minus b, b tells us about the horizontal shift. Horizontal shift. That means the graph have shifted to the right. When we have a negative means the graph shifted to the right. If we are going to have something like x plus b, well, that means the graph have shifted to the left. I want you guys to note that it means the graph have shifted to the left. So if I give you the graph of H and I say go and plot it, well, you will realize that when you substitute a 0 here, it's a 0. When you substitute 90, it's 0.8. Let me remove this. Just gonna remove this. Is 0.8. 0.8 is going to be somewhere there. And then you go for 180, it will be at 0. And then you substitute 270, it's gonna give you negative 0.8. It will be somewhere here. And then 0, it will be here. It will be at half. It will be at half. It will be kinda at half. So it means your graph will kinda be like, if you find a number here, especially the number in the middle, I believe is 135. If you say 135, it's gonna give you 1, if I'm not mistaken. And then the number here in the middle is going to be I think it's 225 if I'm not mistaken. Then, but by the way, your graph will be something like this. From 180, if you notice, from 180, if we say 180 plus 180 plus 30, because the graph shifted to the right by 30 units, at 180 you see 180, 190, at 200, 210. So you're gonna be at 210. Your graph is gonna come and touch at 210. So at 210. This is because the graph have shifted, you know. It means the graph have shifted, and it's not gonna start at 0. Sorry, it's not gonna start at 0. It's gonna start at -half. So your graph will be something like that, you know. So it shows that the gap between, this is going to be 30 exactly. It tells you that the graph is gonna touch at 30. It shifted from the original 0 to the 30. So my point is, when it comes in the form of sine into x minus b, the graph shifted to the right or it shifted to the left. I want you guys to note that down, okay? Once you know how to draw the graph, the better. So I want us to look at the cos graph before we go to the tan graph and understand also, which is very, very easy. It's nothing really hectic. Once you know how to plot, you won't be having any issues. So let's go. Just going to say 90, 180, 270, and 360. Let's start with the graph. Let's start with the graph of y is equal to, by the way, let's make it an f is equal to cos x. Just the original graph. Once you know the original graph, you will know the shape. You go to your calculator and you say cos 0. It's gonna take you to 1. Then we say 90 is going to be 0. Then 180, it will be at -1 down there. Then 270 is going to be 0. And then 360 is going to be 1. So you just have to trace, and you will see that that this is the shape of the cos graph. This is how it's going to look like when you draw. So the amplitude of cos is this, and if we say give us the range, well, the range of the graph is the graph started at 2, I mean at 1, it never goes up. It's gonna go down and end at -1 and then go up again and stop at -1. So your range here will be y is the element of 1 and -1. That's how you give the range of the graph, okay? So once again, if we were to draw the graph of g of x and say cos x plus 1, okay, let's make it -1 this time around. Let's just say -1, and then you go to your calculator and say cos, it's going to open the bracket for you and say 0 minus 1. It's going to take you at -1. And then if you substitute 90, it's going to take you at -2. And then at 180, it's going to take you at -3. And then if you go for 270, it's going to take you at -2. Then 360 is going to take you at -1. No, it's going to take you at -2. And then 180, because this is how the graph will look like. I want you guys to use your calculator, and it's gonna, yeah, I think it's gonna be there. This is going to be -1. Yeah, it's gonna go down. Just confirm with your calculators, guys. I think I was right. It's gonna occupy 2 spaces. Yes, it's going to be at -3, and then -2, and then -1. So this is how the graph will look like. So since it's -1, your graph will be, let's see, I think it went 2 units. Let's make it 2, because I can see that I used a 2. So yeah, let's use a 2. If we set a 2, cos x minus 2, it's gonna go from -1 to 0 and to -1. So it means it went down by 2 units. I mean, if it's 1 unit, I'm pretty much sure this is how the graph would look like if it went 1 unit down. But just to make things interesting, I think I went with a -2. That means you are going to draw this at -2. This is your new axis now. Do you realize that your amplitude now is still 1? Amplitude is 1, and even there the amplitude is still 1. This is to show you what really happens. So we can also see something like cos x minus 30 or plus 30, but just know what it means. When it's a negative, it goes to the right. When it's negative, it goes to the left. You just use your calculator and you will see the points. You will see where the graph went, whether it went left or to the right. So I wanted you guys to know how to plot these functions. Here's the last one. The last one, it will be a tan, a very interesting one. If you look at the graph of tan x, when we draw it, I'm gonna draw it like this. I'm gonna put 90 here, 270 here, 180, 270, 360, -90, -180, -270, negative this, then we have -1, -2, 1 and 2. Before you do that, the graph of tan has what we call a vertical asymptote at 90. You're going to draw a line. That's the first thing that you're going to do. You draw a line, and then you draw another one at at 270. You draw another one at -90, because even if you go to your calculator, it's going to give you an error. This is to show your graph is not going to touch 270 or 90 by any chance. If you put a 0, it's going to take you to 1. If you press 90, it's going to tell you no. So you just have to find the number here in the middle, which is 45. If you say 45, it's going to take you at 1. If you say -45, it's going to take you at -1. So immediately, this is how your graph will look like. Your graph is going to try to avoid touching that line, and it's going to go like that also, and it's going to try to avoid touching that line. And then you say 180, it's going to give you 0. You can try 135 here, and it's going to give you 1. So your graph will be something like that. Then no, 135 is here, so 135 it's here, and then here's 225 if I'm not mistaken. And then you can do this. Once you know the shape, it will be okay. And then it's going to be something like that. Even this side again, you can check, it's gonna be like this, and it's going to be like this. So that's how the graph will look like, and this side is going to be like this. Like I said, you can find the number in the middle. You can say -360 plus -270 divided by 2, and then you get the value. It's going to be 225 if I'm not mistaken. It's going to tell you it's 1, so you just have to put a point there. This one also, it will give you -1. Just find the number in the middle, which is -135. It's going to take you to -1. It's going to take you to 1. So that's how you can draw the graph of a tan. You can just use your calculator, guys. And then this, by the way, is f of x tan x, and I want us to draw the graph of g and say negative tan x. With the negative tan x, the graph is going to be flipped, which is very interesting when you think about it. It's going to flip. It's just going to look the other way. It's gonna look the other way, look the other way, and look the other way. and loop the other way. It will be reflected, by the way, it will be reflected by those x-axis. It will be reflected by the x-axis. So that's how the graph of tan is going to look like, the graph of negative tan and the graph of tan. It can also go up. It means your graph will start at for example, if it goes up, if we set +1, your graph is going to start like this and then go down like this. You know, you'll see something like that if it went up. So you'll see something like that. So, but I can't make that mess here. You will see when you plot, or your graph went up a little bit. You can try to plot. You will see exactly how the graph will look like. The graph of tan does not have an amplitude, guys. It does not have an amplitude. So that's how it will be. Well, there are so many things that I want us to learn. By the way, we're gonna stop here now because I want us guys to learn how to draw them. Once you learn how to draw them, the easier it will be to understand. My next video, it will be recorded. It's not going to be live. I'm going to show you a real life question from a previous question paper from grade 12. I'm gonna post it here. You will see how the knowledge of drawing the graph really helps in answering some of the questions. Okay, so in this case, guys, I believe you will find it well, and all the best.